Welcome to the deep dive. So here we are in early July 2026. And back in June, a switch just essentially flipped in the Pacific Ocean.
Yeah, really massive switch.
Right, so this huge reservoir of heat started sloshing eastward. And it's this shift that is like actively rewriting the global jet stream right now. It's crippling international fertilizer supply chains and, frankly, pushing our power grids to the absolute brink.
It's intense.
It is. So today, for you listening, our mission is to synthesize this stack of brand new, really urgent alerts. We've got data from NOAA, the World Health Organization, the World Resources Institute, and the International Research Institute for Climate and Society, plus some recent on-the-ground reporting from The Guardian.
Right, because we really need to look at what happens when a natural planetary scale climate cycle slams into our very fractured geopolitical landscape.
Exactly. And all of this is happening right in the middle of the hottest decade in human history. So the big reveal here is that in June 2026, NOAA officially declared the formation of El Niño.
They did, yeah.
But the IRI data suggests this isn't just your standard event. There is a 63% chance that this evolves into a super El Niño peaking later this year. So, okay, let's unpack this, because before we can talk about the global fallout, we really need to understand what is physically shifting in the water right now.
Right, we have to start with the engine itself.
Yeah, and like Super El Nino sounds like the title of a Hollywood disaster movie. But scientists are using it in a very specific technical way here.
They are, yeah. I mean, the terminology is definitely striking, but it's based on a very strict mathematical threshold. So to see why they're using that word, we have to look at the Niño 3.4 index.
Which is what exactly?
It's basically a metric that isolates the sea surface temperatures in a very specific critical region of the equatorial Pacific Ocean. And according to that mid-June IRI data, that index has spiked to positive 1.7 degrees Celsius above average.
Wow, okay, and what's a normal El Nino trigger?
A standard one is triggered at just half a degree.
Oh, wow, so we are way past that.
We are, and that super designation, or, well, technically a very strong El Nino, is officially declared at a positive 2.0 degree anomaly. So we are essentially knocking on the door of that threshold right now.
I mean, 1.7 degrees doesn't sound like a lot if you're, I don't know, deciding whether to wear a jacket outside.
Yeah.
But when you scale that up to millions of square miles of open ocean, that is just a staggering amount of thermal energy.
It is, and it becomes even more concerning when you look below the surface. The data shows that subsurface ocean temperatures in the central eastern Pacific are currently up to 6 degrees Celsius warmer than normal.
6 degrees? That's huge.
Yeah, it's a massive, deep reservoir of heat. And what it's doing is breaking down something called the Walker circulation.
Okay, I read about this. So in a normal year, you have these really strong trade winds, right? This massive east-to-west airflow across the Pacific.
Exactly. And those winds act almost like a plow, pushing the warm surface water toward Asia and Australia.
So if I'm picturing this for a second, the Walker circulation is almost like a giant atmospheric treadmill. Like it's constantly running, pushing the warm water over to the western side of the pool, which then allows the colder water to rise up in the east.
That analogy works perfectly, yeah.
But right now, it's like someone just pulled the plug on that treadmill.
Right. The power is out, the winds die down, the treadmill stops running, and all that warm water that had been piled up in the west just, succumbs to gravity. It comes sloshing all the way back east towards South America.
Man. And this is so significant that it actually forced scientists to change how they measure the whole thing, right?
Yes, exactly. NOAA recently adopted this new metric called RNI.
The Relative Oceanic Niño Index.
Right. Historically, they used a static 30-year baseline to define what average actually meant. But because the entire globe has warmed so much, that old baseline just became fundamentally unreliable. It's like NOAA finally updating a laggy smartphone operating system because the old one just couldn't process modern apps anymore. Like the environment changed, so the math had to change too.
That's a really great way to put it. RNI evolves month to month now. It accounts for a shifting climate baseline, which gives meteorologists a much sharper, more accurate picture of how this specific heat reservoir will actually alter the atmospheric circulation today, rather than, comparing it to the 1990s.
Okay, let me jump in here, just play devil's advocate for a second. Because if I am listening to this deep dive in my car in Chicago, or maybe I'm walking to work in London, a 2-degree ocean anomaly in the middle of the Pacific feels incredibly distant.
Sure, it seems far away.
Right. So why does a warm patch of water thousands of miles away get to dictate my local winter forecast?
Well, it comes down to a meteorological concept called teleconnections.
Still a connection.
Yeah, think of the atmosphere less like empty space and more like a fast-moving continuous river of air. That massive pool of warm water in the Pacific, it violently heats the air directly above it. And warm air expands and rises.
Exactly. Which creates massive high-pressure systems. Those systems act like giant boulders dropped into the middle of our atmospheric river, forcing the global jet stream to completely change its course to flow around them.
Oh, I see.
So for you in the U.S., an El Niño winter typically forces the jet stream much further south than usual.
Which means the weather patterns just entirely decouple from their norms.
They do. So like in the northern Rockies and the Ohio Valley, you end up with much drier, warmer conditions. But across the southern U.S., it becomes significantly stormier and wetter.
Right. And according to the NOAA alert we were looking at, that southern shift also brings a much higher risk of high tide flooding all along the West Coast.
Yeah, that coastal flooding is a direct result of those shifting pressure systems. And, the ripple effects don't stop at the shoreline either.
What do you mean?
Well, in the Atlantic Ocean, the altered upper-level winds essentially act like a scythe. They shear the tops off developing hurricane formations, which actually suppresses the Atlantic hurricane season.
Oh, wow. But at the same time, I assume it does the opposite somewhere else.
Exactly. Simultaneously, those same conditions supercharge hurricane development in the Pacific.
Wow. So the boulder in the river redirects the flow for the entire planet. But, as we pivot to the WHO data, the stakes go way beyond whether you need to buy snow tires or an umbrella this year.
Oh, absolutely.
To truly understand the gravity of a 2-degree anomaly in 2026, the data really urges us to look back at the fallout from the last major crisis in 2015 and 2016, because a shift in weather fundamentally alters global human health infrastructure.
Yeah, the 2015 to 2016 event, which really mirrored the infamous 1997 to 1998 Super El Nino, it really laid bare the extreme extremes of this climate cycle.
Extreme extremes.
Yeah, if you look at the Horn of Africa during that window, the contrasts are just jarring. Ethiopia experienced its worst drought in 30 years.
30 years.
Right. We are talking about a scenario where up to 18 million people required emergency food assistance, and nearly 400,000 children were pushed into severe acute malnutrition.
And then, on the exact opposite end of the spectrum, literally just next door in Somalia, you didn't have drought.
No, not at all.
You had these devastating torrential floods that affected 145,000 people and triggered massive cholera outbreaks. It's just complete geographical whiplash.
It really is, and the secondary effects were just as severe. As the baseline temperatures warmed during that cycle, disease vectors physically moved.
Like mosquitoes.
Exactly. Mosquitoes carrying malaria and dengue fever migrated into highland regions that were historically much too cold for them to survive.
Right, because it's warmer now.
Right. And the World Health Organization was stretched so thin they had to deploy something called EWRS in a box.
Yeah, the early warning and response system. I
Yeah.
saw that in the notes. It's fascinating. It was a literal physical field kit, right?
Yes, a ruggedized deployable kit containing solar chargers, laptops, and specialized software. They sent them to 1,000 different health centers to rapidly establish disease surveillance for up to 10 million displaced or vulnerable people.
That's incredible. They had to build a digital health grid from scratch in the middle of a disaster zone.
They really did.
Okay, but here is where it gets really interesting for me, and frankly, a bit counterintuitive.
Okay, how so?
Well, the Somalia floods spreading waterborne diseases like cholera, that makes intuitive sense to anyone, right? Dirty water spreads everywhere, it contaminates the drinking supply, people get sick.
Right, it's a direct line.
But the WHO report specifically highlights major outbreaks of communicable diseases like scabies and meningitis in Ethiopia.
Yes, it does.
So how exactly does a lack of water, like a severe drought, directly trigger massive outbreaks of diseases like that?
Well, a drought is rarely just an agricultural problem. It's really the first domino in a cascade of societal collapse.
Okay.
When the local wells dry up and the seasonal crops die, families can no longer survive on their land. So they are forced to migrate, often ending up in dense displacement camps or urban slums. Suddenly, you have a massive population spike in an area with zero infrastructure to handle it. Then the WASH conditions, that's water, sanitation, and hygiene, they just completely disintegrate.
Because there's no water.
Exactly. There simply isn't enough water available to wash hands, clean cooking utensils, or sanitize living spaces.
So you have people packed shoulder to shoulder, completely stripped of basic hygiene tools.
Right, and that's just the environmental factor. The biological factor is the malnutrition we touched on earlier.
Right, the 400,000 children.
Yeah. Severe acute malnutrition literally obliterates the human immune response. The body basically consumes its own defenses just to keep the organs running.
Oh, wow. That's horrifying.
So you now have a highly vulnerable, immunocompromised population living in incredibly close quarters without the ability to wash. That is the exact mechanism that allows a disease transmitted by skin-to-skin contact, like scabies, or an airborne respiratory illness like meningitis, to just rip through a drought-stricken population like wildfire.
Man, it's a complete biological and infrastructural domino effect.
It really is.
And that brings us to the core of why 2026 is uniquely dangerous. Because, as devastating as 2015 was, the experts at the World Resources Institute make a very sobering point.
Yeah, the threat multipliers.
Right. This current El Niño is colliding with two modern phenomena that we really didn't have to deal with a decade ago. The first is a much hotter climate baseline. Because, the last 11 years have been the warmest on human record.
And that elevated baseline fundamentally changes the physics of the atmosphere.
How so?
Well, our warmer atmosphere has a higher capacity to hold water vapor. It becomes thirstier, so to speak.
Thirstier?
Yeah, it acts like an immense sponge, aggressively sucking moisture out of the soils, the forests, and the crops at a highly accelerated rate. So it turns a moderate lack of rainfall into a severe, ground-cracking agricultural drought much faster than it historically would have.
See, I want to push back on the weather side of that, though.
Okay, go ahead.
Because the WRI data noted something kind of curious. They mentioned that some regions experiencing drought might actually see increased heavy rainfall as El Niño sets in.
Right, that could happen.
So if you're a farmer staring at dying crops and the sky finally opens up with a massive concentrated rainstorm, isn't the crisis over? Doesn't that heavy rain solve the water shortage?
It seems like it should, right. But the mechanics of the soil tell a totally different story. This is a really crucial paradox to understand.
Okay.
When soil is severely dried out and baked by that thirstier atmosphere we just talked about, its physical structure changes. It becomes hydrophobic.
Hydrophobic, meaning it repels water.
Exactly. It gets hard and almost completely impermeable. Now, if rain falls in a gentle, prolonged drizzle over several days, that hard earth can slowly soften and absorb the moisture.
But El Niño doesn't typically bring gentle drizzles.
No, it does not. It brings intensely concentrated bursts of heavy rain.
So the water just hits the baked earth and bounces off.
It acts like concrete. The water pools instantly, creating really dangerous flash floods. It strips the topsoil and runs off directly into the river systems and out to the ocean before it can ever percolate down to replenish the deep groundwater reservoirs or the root systems of the crops.
So the farmer gets all the destruction of a flood, but keeps the underlying drought.
Exactly.
That is just brutal. And, that leads us to the second modern phenomena acting as a threat multiplier this year. Our heavily fractured geopolitical landscape.
Yeah, this is a major factor now.
Right, because we are pulling from reporting by The Guardian and the WRI detailing this ongoing severe global fertilizer and fuel crisis.
And we need to be clear about the origin of that crisis, too. It is deeply tied to the current geopolitical tensions, specifically the U.S.-Iran conflict and the subsequent closure of the Strait of Hormuz.
Which is a massive bottleneck for global shipping. And, it's important to note, for you listening, we're absolutely not taking any political sides here. We're just impartially reporting the data from the sources. Regardless of where anyone falls on the political spectrum regarding those conflicts, the raw economic reality on the ground is that the closure has shattered the supply chains. We were purely looking at the math of how goods move or, how they aren't moving right now.
Right, exactly. The disruption to the fuel and fertilizer markets is staggering. And when scarcity hits, psychology basically takes over.
Meaning countries panic.
Pretty much. We are seeing a massive spike in protectionist policies. Nations are looking at the El Niño forecast, they're looking at their own domestic food security, and they are hoarding whatever resources they have.
Sources mentioned Russia, right?
Yeah, Russia, for example, has halted export licenses for ammonium nitrate, which is a foundational component for global fertilizer. China and several Gulf states have aggressively locked down their own fertilizer exports as well.
So if we connect this back to that farmer dealing with the flash flood on the baked soil, Just as they are facing this extreme crop-destroying weather whiplash, the price of diesel to run their irrigation pumps goes through the roof.
Yep.
And the fertilizer they desperately need to coax a harvest out of their surviving crops is either completely unaffordable or literally trapped behind an export ban.
The global conflict has essentially stripped away their only tools for adaptation.
It really reveals how incredibly fragile our interconnected systems have become. We kind of treat food, energy, and weather as separate categories, but they are deeply braided together.
They absolutely are. And the vulnerability really starts with the global food supply. Just 4 crops, wheat, rice, maize, and soybeans, provide over 60% of all the calories consumed by humanity.
60%. That is wild, and the research highlights that all 4 of those specific crops are highly vulnerable to the exact drought patterns that El Niño predictably creates in major agricultural hubs like India, South Africa, and Brazil.
Right. And the vulnerability cascades from agriculture directly into the energy sector.
How does weather break the power grid, though?
Well, take Colombia, for instance. They rely on hydropower for roughly 65% of their national energy generation.
Oh, I see where this is going.
Yeah, previous El Niño cycles brought droughts so severe that the reservoirs literally dried up, and they were forced to implement nationwide rolling power rationing just to keep the grid from collapsing entirely.
So you have a blackout rolling across the country right in the middle of a historic heat wave.
Exactly. And the inverse is happening across Asia. As El Niño heat waves settle over densely populated regions, you see massive, sustained spikes in demand for air conditioning.
Because everyone is just trying to survive the heat.
Right. And to meet that sudden surge in baseline load, countries have to burn whatever fuel is cheapest and most readily available. That usually means coal.
Let me guess, coal usage skyrockets.
It does. Coal currently provides around 70% of the electricity in India and 55% in China.
Wow. So an anomaly in ocean temperature essentially forces a continent to burn more coal, which pumps more carbon into the atmosphere, which directly compounds the baseline heat we talked about earlier.
It is a terrifying feedback loop.
It really is. And while the terrestrial systems are failing, the marine ecosystems are collapsing simultaneously, right?
Yeah, we have to go back to that Walker circulation treadmill we discussed in the beginning.
Right, the wind pushing the warm water.
Exactly. When the winds push warm water west, it allows deep, cold, nutrient-rich water to well up along the coasts of the Americas.
Which feeds the fish.
Yes, that upwelling is the absolute lifeblood of the Pacific marine food web.
But because the treadmill stopped and the warm water sloshed back east, that cold water just gets trapped at the bottom.
The upwelling just ceases entirely. And without those nutrients, the microscopic phytoplankton starve.
And when the phytoplankton crash,
The small feeder fish, like the anchovies and sardines, they experience massive population crashes. And that sudden absence of prey forces large, commercially vital predatory fish to migrate into completely different waters, utterly devastating the local fisheries and coastal economies that rely on them for survival.
man, it's all just so connected. The ocean starves, the farms flood, the forests dry out. And the data actually notes that during the 2016 and 2024 El Niño cycles, massive fires in the Amazon burned over 2.3 million hectares, just because the environment was turned into a tinderbox.
It's staggering to think about.
It is. But of all the data points, the one that stands out to me as the most alarming is the human element. The Guardian's analysis points out that 21% of all civil conflicts since 1950 are statistically linked to these exact types of climate patterns.
It's a really vital statistic because it contextualizes the threat. A climate shock doesn't just create a civil war out of thin air, obviously, but it acts as the ultimate threat multiplier. We saw this tragically play out in places like Sudan and Darfur. You have existing social inequalities, historical grievances, and fragile institutions. When you add consecutive harvest failures, doubling food prices, and severe resource scarcity to that mix, the social contract just snaps.
Yeah. Okay, that is a mountain of heavy, complex, and frankly, terrifying information.
It is a lot, yeah.
But the goal of this deep dive isn't to just leave you staring into the abyss of inevitable system collapse, because buried in all of these reports from the WHO and the WRI is a major pivot.
A really important one, yeah.
The one strategic advantage of El Niño is that it doesn't sneak up on us. It provides months of highly accurate advance warning, and global organizations are finally figuring out how to weaponize that predictability.
What's fascinating here is that this is really the most significant paradigm shift in modern disaster management.
Tell me more about that.
Well, For decades, the global strategy for extreme weather has been almost entirely reactive. You wait for the hurricane to hit or the crops to fail, and then you try to scramble billions of dollars in relief aid to a devastated region.
Right, which is always too late.
Exactly. But now we are seeing a massive shift toward proactive, anticipatory action.
The UN's Food and Agriculture Organization is a prime example of this, right?
They are, yeah.
Instead of waiting for a predicted flood to wipe out a village and then flying in bags of rice, they are using anticipatory actions. They are literally distributing digital cash transfers to vulnerable families months before the extreme weather is forecasted to hit.
The economic logic behind it is just brilliant. If you give a family cash ahead of time, they have agency.
Right, they can make their own choices.
Exactly. They can afford to hire transport to evacuate their livestock, reinforce their homes, or move their families to higher ground safely. It allows them to preserve their existing livelihoods rather than forcing them to lose everything and then rely on international aid to rebuild from zero.
And the FAO is also utilizing the forecast to distribute short-cycle, drought-resilient seeds to farmers way in advance.
Yes, so the farmers can entirely pivot their planting strategies to match the incoming weather before the dry season even begins.
And that is just so smart. And we are seeing that it isn't just about top-down UN-funded programs either. The WRI data heavily emphasizes how crucial indigenous land stewardship and community-based management have become.
Oh, absolutely. Local communities aren't waiting for the government. They are actively conducting controlled burns and clearing dead brush to reduce fuel loads in the forests themselves.
Which has proven to be one of the only effective ways to stop those catastrophic millions of hectares megafires from sparking in the first place.
It's true. It proves that adaptation is possible when we act on the data rather than just reacting to the disaster.
It is deeply encouraging to see local historical knowledge syncing up with advanced meteorological forecasting to build a real defense.
It really gives you some hope.
So we have covered a massive amount of ground today. We've tracked a warming patch of water in the Pacific as it breaks down atmospheric treadmills, pushes the global jet stream off its axis, and alters the survival zones for diseases in the highlands of Africa.
We really went everywhere.
We did. We've seen how a thirstier atmosphere collides with a fractured, war-torn fertilizer market, and how that intersection tests the absolute limits of our food and power grids. So, as a listener, what does this all mean for you?
The biggest takeaway is that weather is no longer a purely local phenomenon. We live in a world where a 2-degree temperature anomaly thousands of miles away is going to actively interact with global supply chains.
Right.
And those interactions will inevitably ripple out to affect the cost of your groceries and the stability of your thermostat.
Which leaves me with one final provocative thought for you to mull over as you go about your week.
What's that?
Well, over the last few decades, we have aggressively optimized our global supply chains for maximum efficiency and maximum profit. We decided to grow our 4 main crops in a few specific, highly centralized global hubs. We rely on just-in-time shipping to keep warehouse inventory costs as low as possible. We centralize our energy grids.
Right, efficiency above all else.
Exactly. But in doing all of that, in stripping every single ounce of slack out of the system in the name of efficiency, did we accidentally engineer out our resilience?
Oh, wow. That's a great question.
When a natural, entirely predictable planetary cycle like El Niño arrives and pulls the plug on the treadmill, our highly optimized systems suddenly look terrifyingly fragile.
It is the ultimate stress test of a modern interconnected world.
It really is. So, keep a close eye on your local grocery store prices and your energy bills over this next year. See if you can spot those invisible ripples from the Pacific making their way into your neighborhood. Thank you for joining us on this deep dive. We'll catch you next time.